Hi there! In this video we will have a code practice. We are going to explore how I can build up Grafana dashboard using Evidently for evaluations. That's very convenient because Evidently can manage for you metrics and test evaluation, and in Grafana you will explore dashboards and maybe get some alerts if you implement them. So let me start from the Grafana installation, because for setting up the Grafana we need to have a database where we store all the data and which Grafana we'll use as the data source, and everything should be working fine together. For doing that I prefer to use Docker Compose because it's quite convenient to configure several services interacting with each other. I already created Docker Compose file and it's available in course repo, so if you want to follow along with me, do not hesitate to clone our repo and navigate yourself to Grafana monitoring dashboard directory. This is the 6th module of course. Here you will find Docker Compose file, and here we have several services. We have database, Postgres, which is source database for our Grafana. Here is Adminer, that's just a web tool to see what's going on with our database and explore its content. We are going to just take a look to our metrics with help of this Adminer, and our metrics will be stored in Postgres database, right? And finally, here is the Grafana. I use the following version of Grafana image, and I specified a couple of volumes so that we can automatically connect Grafana with the data source we use, which is PostgreSQL. And also, if you want to later save your configurations for the dashboard, it makes sense for you to create this dashboards directory and save your dashboards configurations there. I believe I won't be able to build something very beautiful today to save to you, but just in case you want to save something, that's the option how you can do that. Later you will need to save the configuration, for instance, from Grafana web interface. If I'm not forget, I'll show you how to do that if I not forget, and you will need to save those configurations into a dashboard folder. And we also have a config folder with Grafana dashboards configuration and Grafana data sources configuration. So that helps Grafana to see where data source is. Right? That's all available in our course repo. And finally, we will need to implement a script, an example, where we are going to calculate some metrics, simulate the production service which sends data to the PostgreSQL database. In our case, we're just going to insert the data directly to our database and see how we can build up a dashboard using Grafana from evidently calculated metrics. Well, that's it. In order to run it, we will need first to run Docker Compose so that our database and our Adminer and Grafana works, and then we will run our script which creates a table in our PostgreSQL database and then sends data to this table. Let me create a script for us. I will call it metrics calculation and logging. Here we go, that's our script, and now let's implement the logic. I will start from importing Python libraries. It's here. And maybe it makes sense to mention that actually for Grafana example I have quite a lot of requirements. I placed it all here in requirements.txt, so do not forget to install all the dependencies before you actually implement and run the script. Here are quite a lot of things related to working with databases, working with Postgres database, so do not forget to install that. And going back to our script. Here we're going to work with a lot of services, database, Grafana, so I really need to set up a login here in case we will need to debug something. Yeah, I believe it should be fine. So we will have a time, level name, and the message. Yeah, I believe it should be enough to figure out what's going on here. Okay, then in order to create a source data for our Grafana, we need to create a database and a table inside of this database. Let me implement table creation statement here. It will be pretty long, this is why I prefer to have it like separately and then use it inside of the function where I'm going to create this table. Traditionally, before creating a table, I check if it exists or not, and I drop it if it exists. The reason is that every time I run my script, I want to start from the empty table, right? And this is why I better just create it from scratch every time. I think I will limit myself with just 2 metrics because I'm going to build 2 panels, and I believe if you need more, you will just get inspired by this example and add more metrics yourself. So I'm going to add timestamp and 2 values, target drift and share of drifted features. That's 2 my favorite ones probably because I already used them before. So timestamp with type of timestamp and target drift, float, because I'm going to have this drift score, and share of drifted counts. Now let me load our data. Again, I'm going to create global variables. And I will just go back to the previous example where we simulated the production usage of our service, and I will just derive a couple of instructions with mini-batch logic. If you haven't seen the previous video, then the idea is that we just load the dataset from scikit-learn. It's bank marketing data, binary classification problem, and the idea is that we try to simulate that our machine learning model works as the online service, right? And we have some reference data, the first part of our data set, and then we just simulate the production usage by sending the mini batches of data. Each mini batch is equal to 50 rows of our data. So that's how we simulate that we have this service which sends us data. Well, that's it. And now let me prepare my database to be used as the data source for Grafana. For doing that, I need to create a database, then create a table, and then start inserting data in this table. And I will have the separate function for setting up database and table. To work with PostgreSQL from Python, I'm going to use Python adapter. I already imported it right here, so now I can interact with my PostgreSQL database. And well, I'm not sure about the port, and I will quickly go back to my Docker Compose so that I can check the port for Postgres. It's 5432. Anyway, let me just copy it here. So that's how I connect to my database by host, port, introducing a user and a password, and now I can create the table. First of all, let me make sure that the database is set up correctly. I will do it with help of just simple query. Here is my simple statement with which I check whether I already have my database, and if not, I just create database test and then I will create my table. Let's proceed to it. Now I have a function which prepares for us database and a table, and now it's time to implement an actual function which will calculate metrics. Let's do that. Calculate metrics PostgreSQL, because we are going to implement some logic to insert those calculated metrics into PostgreSQL table, so I want to reflect to this in the function name. First of all, let's create a report. And here in parameters, car goes for cursor, and I should be used for simulation that we have several batches, and I is the number of batch. You're gonna see the details a little bit later when I implement the logic. So first of all, I create my report, which consists of two metrics, dataset drift metric and column drift metric for a target variable. Then I'm going to run calculations, then turn the results into a Python dictionary, and finally derive needed metrics, right? After I derive needed metrics, I will be able to create a query which insert those metrics into a table. Let's proceed to it. Well, at this step we have our results of the report calculation in the dictionary format, and now we need to derive needed values from this dictionary. Luckily, I quite remember the structure, and you guys can go to the documentation or just run this report and see the output of sdict method. And yeah, I know that we need to derive these values, and well, should be somewhat like this. Evidently stores metrics as the list, and you can access those metrics by index. So my first metric is dataset drift, so the target drift should be under the 1 index. So let me try to remember. It's metrics, and then 1, then result, and here I have metric result, and I believe it's just drift score. And well, for share of drifted features, share of drifted columns should be very similar, but now it's the first metric, so it has index 0, then result, and instead of drift score, it's share of drifted columns. Okay, so now we derived all the needed values, and we can insert it into our table. Let's do it. I will just create the SQL query here. And let's just copy the name of our table so that we do not misspell something. And then our structure, which is timestamp. Then target drift. And finally share drifted columns. And our values, 3 ones, 1, 2 and 3. And now let's pass actual variables, which is first timestamp. I would go for now, datetime now, then target drift and share drifted columns. Now it's done. Now I have a function which calculates for us a couple of metrics and then insert this into our database, right? Into our table in our database. Now let's implement a function which will simulate the process of service usage and inserting the data after receiving those data inside of the table. I would call it monitoring backfill because basically that's what we are going to do here. First of all, I need to prepare my database, so I call this function from here. Then I need to connect to this database and call calculate metrics PostgreSQL function every time we receive some data. I'm going to copy this instruction. And I hope there are no misspells here because I already copied it before. Here we have our connection. And now I can simulate that we receive data from service, for instance. For doing that, I will just create simple Python cycle. Again, I believe 50 iterations will be enough. I just create a cursor to point to a specific place in my table and I run calculate metrics PostgreSQL function with this cursor and I from my cycle to iterate through my data frame. Then let me add some login info. I need that to see what's going on from my terminal. And finally, let's add some sleep so that we can see how we're progressing with the loading more data. Just to simulate like we have a production service which sends to us data and we see our dashboard with the updated plots in real time. I think 3 seconds will be enough. So that will be the time between the iterations of sending data to our database. Okay, and let us finish up our script. But instead of main, let it be batch monitoring backfill. Now it looks good to me. As usual, I believe we would need to do some debugging, but first let us run our services. I'm going to go back to terminal and I'm going to run Docker. It creates container for us. Let us wait until we have everything. Let's go and access our services from browser. Grafana should be running at port 3000, so let's see. Yeah, it asks for login and the standard couple of password and username are admin. It asks us to update it, so update it. And here we are. So we can see that our Docker Compose works and our services are working as well. Now let me open up one more tab. Let us run our script and see whether we are able to log some data to the database. Yeah, it's finally running. I can see the data sent. And let me go and access first Adminer before Grafana because I want to check whether I was able to actually create a database. with the table, so I access it by localhost. I go to PostgreSQL, my username is Postgres, then password example, and database test. Login. Oh, surprisingly, there are no tables here, but actually I expected to have my drift metrics table here. Let me go back to the script and see what's going on there. So it's definitely prepared database function. First of all, I connect, and I connect correctly. Then I try to select something from my database, and it's created actually. Then I create database test. Okay, I see it. So basically, I haven't specified which database use here. So I will do it right here. That name is equal to test. So now my data, now my table will be created inside of test database. So let's save it. Let's go back here, just interrupt our script and run it again. That name, why it's not, sorry, not that name, the database name, of course. DB name, yeah. So let's go back here, we run our script. Yeah, again, it started to send some data. Now let's double check in Adminer. Yeah, now we have our table here. If we open it up, we can check the structure. It has timestamp, target drift, share drifted columns. Right, exactly as we expected, and types are correct. Now we can select some data. No, something is wrong with that again. Let us check what's going on here. Probably that's the same problem, that we did not specify our database name, so let's do that. I will save changes, then I go back, interrupt my script again. So yeah, when we work with databases, it's a little bit tricky sometimes, especially if we do not do it regularly. So I'm going back to Adminer. Let me check it again, and yeah, finally I have some data. Yeah, it's coming, and now I can go to Grafana, create new dashboard, add new panel, and probably if I select PostgreSQL here as the data source, it will, it shows me my drift metrics table. So I can add column target drift, and it starts to show me the results. Maybe if I change from last 5 hours to last 5 minutes, it will be a bit better. Cool. So how do I add one more value here? Yeah, let me select share drifted columns, and now I can see 2 lines in the same panel. You can do very same, you can add separate panel and have your share of drifted columns there. It's totally up to you. And now if I can specify the title, I will just call it drift metrics. And then I can apply those changes, and probably I will be able to see, it's already finished, right? So yeah, it was quite fast. Yeah. But you saw how those data was added in real time, so that, yeah, that's pretty interactive thing. That's all I wanted to share with you in this tutorial video. I hope you liked it. And now, if you need to implement your dashboard using Grafana, you know how you can create your custom metrics or calculate some metrics with help of Evidently and integrate it into your Grafana through the data source.